that pink vector, instead of at the origin, I'm going to add it to where my green vector ended, that terminal point right there. So if I start over, remember it was rotated 40 degrees east of north, and it had a size of 8. No, these are not drawn to scale. Obviously, I haven't measured anything. And then our last vector, the yellow vector from dog 3, was due north and had a size of 14. So I'm going to add that to where my pink vector ended, due north, had a size of 14. Where this vector ends is going to be the terminal point of my resultant. After I add all 3 of them together, where that stops becomes the terminal point of my resultant. So if I'm going to connect this point here to my origin, that red vector I just drew in, I'm going to call it U, that is my resultant. It's the size of this vector and the direction of this vector that is important for figuring out the answer to this problem. Okay, so let's start with the magnitude, because the dog walker has to have the same force as the 3 dogs have combined together. So we need to calculate the magnitude of this vector. Well, in order to do that, we have to find the components of the resultant vector. So let's look at how to find the components of the resultant vector. How we do that is we're going to add all 3 of these vectors together. That's why we found the components, the vertical and horizontal component of every single vector. So when I add these components together, I get negative 3.52 in the x direction and 25.13 in the y direction. Now look at this as a coordinate. If I go back to my picture of the resultant, our point that we just got said that this is negative 3.52 in the x direction. That makes sense because my resultant is in the second quadrant. And then our y value is at 25.13. Now note, this isn't drawn to scale, but these answers for the component are reflected in this diagram for the resultant. So we can use these values and calculate the magnitude of that resultant. How do we do that? Pythagorean theorem. We take the square root of the horizontal component squared plus the vertical component squared. Notice my use of parentheses. If you don't put this into your calculator in parentheses, your calculator will not appropriately square a negative number. And we get a size of 25.3753. So this is the force that the dog walker has to have in order to create equilibrium with the 3 dogs. But now what we have to look at is the direction that she has to go. If she wants to achieve equilibrium and the dogs are pulling her this way, she's going to have to pull in the opposite direction this way. So our dog walker is going to need to go in this opposite direction, but with the same size force. So the direction I'm looking for is not this direction from standard position here. It's actually this direction. So if I'm writing this in bearing notation, my resultant vector is in the direction south, some degrees rotating east. I got to figure out what this angle is in here. Now we know what these components are. Okay, even though I'm in the fourth quadrant, I know that this is still has the size where my horizontal component is 3.52, it's just in the opposite direction, and my vertical component is negative 25.13. To oppose this force, she's got to pull in this direction, which is why I changed the signs of the coordinates, the horizontal component and the vertical component. Okay? And the reason I want to do that is because I can actually create a right triangle here. If I look at this as my right triangle, now you could find this angle a variety of different ways. I'm going to use this right triangle that you see right here. Let me draw it over to the side. I'm trying to find this angle in here, that theta. I know that this has a side of 3.52, and this has a size length of 25.13. The length of this triangle is 25.13. The length of this side of the triangle is 3.52. We've already solved for the resultant. We've already did that. Remember, it was 25.753. I'm trying to find this angle. In order to do that, I'm going to use tangent of theta equals 3.52 over 25.13. Depending on how you set up your triangle, some of you might have went from this way, which is what we've been doing. Your tangent would be the opposite. Okay? But since I'm looking at finding bearing notation, I'm saving myself a step by finding this angle in here instead of finding this green theta in there. Either way you go, you will get the right answer. So when I find this angle and I use inverse tangent, that's a 1,3. We get this theta. It's a red theta. I don't want it to confuse you. To be about 7.97 degrees. Remember, that was south rotating east. So if our dog walker wants to oppose the force of these three dogs, then she will have to do so with a force of 25.3753 south, 7.97 degrees east.